Welcome to this video on exploring mixtures and their separation. We'll be classifying substances and mastering scientific techniques essential for isolating materials. This is key content for Class 9 Science. First, what is a mixture? It's a substance made by combining two or more materials without a chemical reaction. Examples include sugar and water, or the air we breathe. Separation is vital for obtaining pure substances, like clean water. Homogeneous mixtures have a uniform composition throughout. The different parts are not visible to the naked eye. The components are evenly distributed and retain their original properties while being physically blended. A well-stirred sugar solution is a great example. In contrast, heterogeneous mixtures lack a uniform composition, and the individual substances remain physically separate. Components are often visible and can settle over time. Mixtures like sand and water or oil and water demonstrate this distinct phase visibility. We express concentration as the amount of solute in a given mass of solution, defining its strength. The mass-by-mass percentage formula calculates this. For example, 10 grams of salt and 90 grams of water is a 10% mass-by-mass solution. Solubility is the maximum amount of solute that can dissolve in a fixed quantity of solvent at a specific temperature. A saturated solution cannot dissolve any more solute. For solids and liquids, solubility typically increases with temperature. Crystallization is the method of obtaining a pure solid in crystal form from a saturated solution. The principle relies on differences in solubility at various temperatures. This process is used to obtain pure salt crystals from seawater by evaporation and cooling. The distillation process separates two miscible liquids based on their different boiling points. A requirement for simple distillation is a boiling point difference of at least 25 degrees Celsius for effective separation, like separating acetone from water. Fractional distillation is used for miscible liquids with boiling point differences less than 25 degrees Celsius. It utilizes a fractionating column for repeated condensation. This is essential in petroleum refineries to separate crude oil into fractions like petrol and diesel. Paper chromatography separates mixture components, like inks or dyes, based on their interaction with a solvent and paper. Components move up the paper at different speeds based on their solubility and affinity, allowing separation of dyes in black ink. To separate immiscible liquids, which do not mix, a separating funnel is used. The principle is based on different densities, causing the heavier liquid to settle at the bottom. An example is separating mustard oil from water. Sublimation is a phase transition where a solid turns directly into a vapor without becoming a liquid. This process efficiently separates a sublimable substance from a non-sublimable impurity in a lab setting. For example, separating camphor from sand by heating. A suspension is a heterogeneous mixture where large solid particles remain suspended. Unlike solutions, these particles are large enough to be visible to the naked eye. Examples include muddy water or sawdust mixed in water. The centrifugation process involves rapidly spinning a mixture to separate heavier solid particles from a liquid. The centrifugal force moves heavier particles to the bottom. This is used in labs to separate red blood cells from plasma for diagnostic testing. Coagulation involves adding a coagulant to make tiny suspended particles clump together and settle. This method is used in water treatment to remove fine impurities. Adding alum to cloudy water causes dirt to bind and form heavier particles, clearing the water. Colloids are mixtures that appear uniform, but have particle sizes between a solution and a suspension, ranging from 1 to 1,000 nanometers. Due to their small size, colloidal particles do not settle over time by gravity. Common examples include milk and fog. The Tyndall effect is the scattering of light as it passes through a colloid or suspension, which makes the light beam visible. Solutions do not exhibit this effect because their particles are too small to scatter light effectively. A familiar observation is sunlight passing through dust in a dark room. Emulsions are a specific type of colloid where both the dispersed phase and the medium are liquids, such as oil and water. Emulsifying agents, like proteins in milk, are added to stabilize the mixture and prevent it from separating into distinct layers. Examples include vanishing creams and body lotions. Alloys are homogeneous mixtures of two or more metals, or a metal and a nonmetal, combined to enhance properties. They are created to produce materials that are stronger, more durable, or more corrosion-resistant than pure metals. Brass and bronze are common examples of alloys. Understanding physical properties like size and density is crucial for designing effective separation tools. These techniques are vital for sustainability efforts, including waste recycling, sewage treatment, and advances in medical diagnostics.